Could we stop global warming by blocking sunlight? Geoengineering, the deliberate large-scale manipulation of the environment to counteract climate change, is gaining attention as a way to quickly cool the planet. One idea is to inject aerosols into the stratosphere, like the stuff that comes out of volcanoes. Here's how it might work and why scientists are hesitantly excited about it. Imagine you're at a beach on a hot summer day. You feel the sun beating down on you and warming up the sand between your toes. You look up and see an enormous cruise ship churning up the ocean water just offshore. It's spewing out tons of black smoke that looks like a giant cloud. But instead of covering the ocean in smoke, what if we covered the Earth's surface in smoke? By injecting reflective particles into the stratosphere, we could bounce more sunlight back into space before it has a chance to warm up our lower atmosphere. It sounds kind of crazy, but scientists are actually seriously considering this idea, which is often referred to as stratospheric aerosol injection, or SAI. It's one of several proposed geoengineering techniques that could potentially slow down or even stop global warming. And unlike some other methods, SAI is relatively quick, taking just a few months to have a noticeable impact on temperatures. But before we start blocking the sun, scientists would like to understand what effect this might have on weather patterns, air quality, and the upper atmosphere. And that's where you come in. This is a real science question from a real kid. A viewer asked, if humans can make clouds, can we also make rain? And the answer might surprise you. Normally, rain happens when water vapor in the atmosphere condenses into liquid water droplets, or ice crystals, that are heavy enough to fall to the ground. But if we were to put extra particles into the air, they could serve as surfaces for those droplets or crystals to form around. So yes, in theory, humans can make rain. Stratospheric aerosol injection is just one of many geoengineering options being discussed by scientists today. The most famous and infamous proposal is solar radiation management, which involves brightening marine clouds so they reflect more sunlight. Some researchers are even looking into brightening clouds on the dark side of the moon, so it could passively cool Earth's surface. Other proposals involve removing carbon dioxide directly from the atmosphere through processes like direct air capture, which pumps carbon dioxide into the ground where it can be stored for thousands of years. But these options aren't nearly as fast as SAI. So let's dive into how it works and what we still need to learn. SAI would involve pumping reflective particles into the stratosphere, the second layer of atmosphere above the troposphere where weather happens. Most of the year, the stratosphere is pretty stable, with very little vertical wind. That means once the particles are injected, they'll stay up there for months or even years without getting mixed down to the surface. These particles would be mostly made of sulfur dioxide, which reacts with water vapor and oxygen in the stratosphere to form tiny sulfate aerosols. These particles are good at reflecting sunlight because they're the right size. If the particles are too big, they'll fall out of the atmosphere before they have a chance to spread around the globe. If they're too small, they'll be hard to detect with current technology. We know that injecting sulfur dioxide into the stratosphere can have a cooling effect because it's been done accidentally before. In 1991, after the eruption of Mount Pinatubo in the Philippines, tons of sulfur dioxide were injected into the stratosphere, and the planet's average temperature dropped by about 0.5 degrees Celsius. Of course, we don't want to rely on volcanoes to save us from climate change. So in 2021, a group of researchers proposed a different approach. Their plan involved 2 ships emitting 100 kilograms of sulfur dioxide every second along a line of latitude about 65 degrees north. Because the particles would spread along the circle of latitude, they'd cover a lot of ground quickly. The cooling effect would be fairly uniform around the globe, except over the poles. And here's another advantage. Injecting sulfur dioxide into the stratosphere doesn't add any new particles to the atmosphere. It just changes the form of existing sulfur compounds. So there shouldn't be any new particulate matter or acid rain, which would harm both human health and the environment. Despite the potential benefits, most climate scientists agree that SAI is a risky strategy. Not only do we need to learn more about how it would affect weather patterns, but there are also ethical concerns about who decides when and where to inject aerosols, and what impact it might have on developing countries. The good news is that thanks to advances in computing power, scientists can now simulate how these systems might evolve under a variety of conditions, and you can help them get even better. By learning about the world through computer models, we can make better decisions about how to protect the environment and our planet's future.